Welcome back. Now that we've taken a look at some of the most common logic gates, I'd like to try this exercise together. So I've drawn some digital circuit diagrams, and what we're going to do is write out, it's called the Boolean expression that corresponds to each of these diagrams. Okay, so let's get started. So what you want to do is identify the different gates that you have in your diagram. And you can do this by referring to the document that I made for you here, right? This document, which is in Blackboard, has all of the gates in it for this course. You'll be looking at other gates perhaps in another course. So this is an inverter, and so is this an inverter. And this, it's straight in the front, so we know it means multiplication, but it also has the circle at the back. So this is called a NAND gate. And at the end here with the round front, this is an OR gate. So we have two NOT gates or inverters, NAND, and here is OR. So we're going to write the expression now that corresponds, okay? So here we have A, but it passes through an inverter, so it is now A NOT. Here we have B, it is passing through an inverter, so it is now B NOT. So then we have A NOT and B NOT multiplied together, and then the product is inverted. Okay, so if you're the kind of person that likes to mark up your diagram, you can do that. So you can put a multiplication sign here, for example. At the end of the inverter here, you can write A bar. At the end of this inverter, B bar. Then they're being multiplied, and then the product is inverted. So coming out here, we have A bar times B bar, and then that whole product is inverted. So that would place a big bar over top like that. So that would be here. Then we come to this OR gate, which means addition. So what is being added to this? We'll just follow the other wire back and you'll find that C is being added to this. And that's how we get our expression for X. So X equals. So again, it's A inverted multiplied by B inverted first. So I'm gonna just use my ruler. And then that product is inverted. So that put a big bar over top like that. And then I've added C. Okay, and then I'm done. I have my final answer. So again, A bar times B bar, all inverted, and then to that C is added. Okay, let's try another one. So here's a second diagram. Again, we could go through and list the gates. So here's an inverter. This is AND. This is also AND, straight in the front, no circle at the end. So these are just AND gates, which mean multiplication. And at the end, we have OR, and so that means addition. Now look, what is being added? 1, 2, 3, 4 things are being added. So in our expression for X, we're going to be adding 4 things, which means we need 3 plus signs, right? So we can put 1, 2, 3, 4 things here that are being added. And then we can just follow these wires back if we like to see what is being added. Okay, so let's try this first one. If we follow this wire back, we get to the AND gate. What is multiplied here? A and B are multiplied. So that would be here, A, B. And the multiplication sign here would be implied. So if you just write AB, it means the same thing as A times B. So that little symbol there is optional. Okay, let's follow the second wire back. Again, it's the product, but what is it a product of? Follow this wire B with not C, but C inverted. So this one is B times C inverted. This third one here, follow it back, and what is it? Plain old C. You'll notice that the wire comes from C here. Actually, I could put a little dot there to show the connection. Maybe we want one here as well. In any case, we're taking C here before it goes through the inverter, okay? Right there, and the following one here, the last one, comes from D. Okay, so that's the expression here. It's AB plus BC naught plus C plus D would be the expression for number 2. All right, let's try our next one. Okay, so here's a diagram I drew. This is example 3. So again, let's just name the types of gates. So here's the inverter. These two are round in the front. We know that means adding. But there's also a circle at the end. So they're not OR gates, they are NOR gates. N-O-R, NOR. So that's NOR, that's NOR. And at the end here, straight in the front, which means multiplication, this is an AND gate. Okay, so let's get started. What is being added here? A is being added with, and again, I could have a little dot there maybe to show that connection. A is being added with B inverted. That's what's being added, and then that is then inverted. So here we have A added to B inverted. That would be here, and then that whole sum is inverted. Okay, and this bottom one here, it's rather symmetric, okay? So what is being added this time? Follow this back. It is B naught added with C, and then that sum is inverted. So B naught added with C, and then the sum is inverted. So that would be here. And then those two things are then multiplied together. And so that's how we write out the expression for X. So we have A added with B naught and then inverted. So that's this NOR gate here. And then that is multiplied by B naught added with C, all inverted. So this corresponds to this NOR gate here. Okay, so that's the correct expression for X. X is the output and X equals this expression. Okay, let's do one last one here together. So again, let's identify the gates. And this one is NAND. See the circle? So NAND and then AND. So they all mean multiplication. Okay, and then at the end we have OR. So that's added. There is no circle at the end here, okay? So this is just OR. So AND, NAND, and OR. So let's write down this one here. What would this gate be? It's the multiplication of A with B. So this is AB. So the dot in the middle is optional. It's implied. This is the multiplication of what? This one, if you follow it back, is B with C. So right here we have BC, but that product is inverted, like that. And the last one here, what is being multiplied? Well, this wire goes back to C, but this one, where does it come from? Follow it. Look, I've got these loops to show crossing the wire here, crossing the wire here, and actually going back to A. So this is actually A times C, or C times A would be the same. Usually we keep it alphabetical order. So this is A times C or C times A. And then those things are added together. Okay, so the three items are then added. So we need two addition signs to write the expression. So we have AB plus BC, all inverted, plus AC. And that's the fourth one. Okay, so I hope you're understanding this. What we're going to do now is the reverse. So I'm going to start with a Boolean expression and attempt to draw the diagram. Now, I don't draw well, okay? These four that I did here, I took my time, and that was honestly the best I could do. So these ones will be worse in terms of the drawings. But the key is that we can all tell what kind of gate it is, all right? So that's what I'm going for here. So let's look at this. So we're going to draw the logic diagram. Here's our first expression for x. We have A plus BC bar, and then that whole thing is inverted. So I'm going to try to draw this. So I have to put my inputs down. A, B, and C are my inputs. Okay. Now it's rather like order of operations here. So I start under the large bar, all right, and maybe I'm going to set up this pair right here first, B times C bar. Okay, it'd actually be a little easier if I didn't space these out quite so much, but it would work either way. I'm going to move them a little closer. So I'm going to draw B times C bar. So what does this mean? It means that my C has to go through an inverter. Okay, so I'm going to draw, oops, I told you I was bad at this. I'm going to draw an inverter here. Okay, so that's my C bar. And now it's supposed to be multiplied by B. So here comes the wire from B. And I want to multiply those two things together. So multiplication means and. Remember, and is straight and vertical in the front. So I'm going to draw that as my AND gate. Okay? Good enough. So straight in the front and then kind of rounded at the back. So I've done this part here. Now what do I have to do? I have to show it added with A. So I'm going to have the output coming out of there, and I'm going to bend it up here to kind of meet the wire from A. Okay, so this part now had to be added with A. So in order to show adding, what do we need? We need it round in the front, round in the front. And so then I'm going to attempt to draw a bit of a OR like that. Okay, so that's OR for me. So that's all this stuff under here. But then the big bar on top means that actually this should be NOR. So I put a circle on the end and then out here. And there we go. That's what I would label as the output X. Okay, so again, take a look. This is B multiplied by C naught. And then it's being added to A. And then the whole thing is inverted. Okay, not too terrible. I'm going to try this one now, all right? So again, we're kind of thinking about order of operations. So I would like to draw this right here first. So A multiplied with B naught, multiplied with C, and then all inverted. So this is NAND. I have to draw a 3-input NAND gate. So NAND, so straight in the front, maybe a little bit bigger, straight in the front, and then round, 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 round. Okay, good enough. So that would be AND, but the big bar on top means I should make it NAND. Okay, so what's supposed to go into here? Well, A and also B naught and also C. So I'm gonna write these out here, A, B, maybe I'll make them a little closer, A, B, C. All right, so A, straight in, but B goes through an inverter first. So I'm gonna put B through an inverter first so that we have B naught. And now it can go straight in. And I have to get C in there as well. Well, I'm gonna have to just, sorry, I could have done a better job if I moved my gate down. Should I move it? Thank goodness for my eraser. Okay, so C, I'm gonna have C here. I could have just bent the wire, but I just thought I'd move the gate instead. So here we go. Let me try again. Here's my AND gate. And now we want to make sure we invert that whole product. So there it is. There's NAND. Okay, so I've done this part, and now all I have to do is add D. So coming out from here, and I'm going to want to add it with D. So obviously I need to show input D. Input D is going to be added now. So to show this addition, we need to draw OR. All right, I'm gonna say that that's good enough. And then out from there should be the output X. Okay, and after you're done drawing it, of course, you can check it. This would be A times B naught times C, all inverted, and then added, round in the front is the key, right? Don't make that straight. Added to D. Okay, next one. Aha. So now, number 3, we have B naught added to, in a bracket, we have A naught plus C naught. Then the whole thing is inverted. Okay, so remember, order of operations. So I'm actually going to do this part first. I want to draw A naught added with C naught. So this brings me to an interesting point. I don't have to put the inputs in alphabetical order like this. A, B, C, D. Since I need A with C here in this OR gate, I want to instead change the order and put A closer to C. So I'm going to have A, C, and then down here B. And that's perfectly fine, and it'll help keep this a little nicer. So I have to put A through an inverter, and also C through an inverter, and B through an inverter. So maybe I'm going to start by drawing some inverters. Okay, so let's do that. All right, so I'm going to draw some little inverters here. Not very well, as you can imagine. But in any case, I will draw them. Okay, so there we go. I drew some inverters, and now A inverted has to be added with C inverted. So actually that means drawing an OR gate. So round in the front. Okay, good enough. And so going into this OR gate should be A naught, so there it is. And then also C naught. So to get my C naught in there, I'm gonna have to bend the wire like that. Okay, so right here, I have now this part inside this bracket. This is A naught added with C naught. And now what happens with that? Well, it is multiplied by B naught. So the implied operation right here is multiplication. So to show multiplication with B naught, we need to have an AND gate. So after this, I need to have AND. So let me start. Okay, so straight in the front. And of course, B naught is meant to be going in there. So I guess I'll just bend the wire a bit there as well. Okay, so did I do that right? So this is A naught added with C naught and then multiplied by B naught. And that's pretty perfect, except there's this big long bar on top, which means we shouldn't have AND here, we should have NAND, like that. And then out. And don't forget to include the X here, okay? And it's really, really important that you only draw one wire leaving the input, okay? All the time. So here's number 3 complete for you as well. And I'm gonna do one more with you here. Problem 4 says AB, all inverted, so this is an inverted product. That's multiplication implied. So that would be NAND. Added to A naught multiplied by C. Okay, now remember we talked about the order of the inputs here. Take a look at this one. What order do you think would work? I'd like to suggest that since the A is in this duo with B, and then it's also in this duo with C, the A kind of has to go in the middle. So the A is going 2 ways. It's kind of 2 timing, if you like. So we're gonna have to put the A in the middle so that it can more easily go off with B. I'll put B here. And it can more easily go off with C. Okay? Now, just like I said though, only one wire can be drawn leaving A. So from there, I can branch off. So from there, I can say, oh yeah, go with B if you want, go with C if you want. All right? All right, so now, I'll put a little dot there. Now let me set this up. I need A times B all inverted. So let's draw a wire from B as well. Bend this one from A. Okay. Multiply and invert, so that is NAND. So let's do that. Straight in the front is the key for multiplication. That would be AND. And then for the big bar, there we go, NAND. So I have now drawn this part. I'm going to try to draw this part. So C is multiplied by A inverted. So I actually have to pass A through an inverter, but I have to do it after this point because this has to be plain old A. So I could have done it on this part, or I can just do it on this part here. So A has to go through an inverter. All right, so that's my inverter. Kind of short, but whatever. So there's A going through an inverter, and that is going to be multiplied with C. So there's my wire from C. And now I have to show multiplication. So straight in the front, round like that. Okay, lastly, so I've got this guy set up here. I've got this guy set up here. Now what's going on between them? Addition. So what does that mean? I need to draw an OR gate. So round in the front and then something like this. I don't know. Okay, looks great. So then, oops. There we go. Just show that wire coming from that AND gate. And this wire coming from that NAND gate. It's amazing. I use a ruler and take my time and still this is the best result. All right, so there we go. Perfect. So, yeah, don't worry too much about your artistic abilities. I'm sure most of you will put my diagrams to shame. All I am concerned with is accuracy. So again, the key is round in the front for addition, straight in the front for multiplication. All right, everything else is pretty easy to draw, okay? All right, so thanks so much for watching, and make sure you practice some of this. Some suggested work for you is listed in Blackboard. Have a great day.